Understanding trigonometric ratios. Communication question 3. Provide an example where sine of an angle will help us solve the triangle. Okay. Now let's first generalize the question, right? And then we will write the answer for the particular question asked. Now here let's consider a triangle, a right triangle with vertices at A, B and C. Correct. Now, what are sine, cosine and tangent? Sine, cosine and tangents are ratio of the sides of a right triangle. So we are considering a right triangle. That is the first thing. Now sine is opposite over hypotenuse. So we write sine as opposite over hypotenuse. And cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Tan is opposite over adjacent. So these are our three basic trigonometric ratios. Now which one to be used in a given situation? So let's consider we are dealing with a problem where we know two things and we need to find the third thing. Most of the time that is going to be the case. And let us consider a case where one angle is given to us and we need to find a different side and we know hypotenuse. Correct? Now if you know angle and hypotenuse, then you know the two things related with hypotenuse are sine and cosine. So one of them can be used. Now if you have to find out opposite side, you should use sine. If you want to find the adjacent side, you should use cosine. That is how you make a decision whether it should be sine of an angle to be considered or cosine of an angle to be considered. But if suppose that the situation is to find the height of a building and you know the distance from the building. So in that case, what is known to you is, let us say, one of these two, right? In that case, we should use tan, because tan deals with opposite and adjacent sides. So let me summarize it here, and I'll make three different triangles and show you in which situation what should be used, right? So let's say these are our three different triangles, and we have some word problems in which, let us say, one word problem is given something here, and you have to find this. Now, since you are involving opposite side, hypotenuse and the angle, the trigonometric ratio to be used is sine. Perfect. Now let us take another scenario where we need to find this and we are given these two things. Correct? In that case, since we are involving adjacent side and hypotenuse with the angle, we should use cosine. Right? Now, if somehow there is a situation where this is given to us, we need to find that and we know this. In that case, the relation should be opposite over adjacent, tan. So that is how we should deal with it, right? I know specifically this question is about sine, right? So we can give you an example based on this. Let us say that somebody is flying a kite. So we have a kite here, right? Let's say that's our kite and that's the thread, correct? And we want to find that if the angle of elevation is given to us, right? And we know that the kite is flying approximately at the height of, let's say, 500 meters, then how much is the thread length, correct? In that case, we know this is 500 meters, correct? And we know, let us say this angle is given to us, let's say the angle is 60 degrees, and we need to find the thread length. Then we should use sine, correct? Because sine is opposite over hypotenuse. And you know, you can use special triangles to find 60 degrees. The 60 degrees special triangle is right here, where you know the side are 1 and square root 3 and hypotenuse is 2. Therefore the answer will be, you know, the ratios, right? sine of an angle is given 60 degrees, correct? That's the sine. So you have square root 3 over 2 is equals to 500 over this length, right? So if you compare, you can find your answer. So that is how you can solve your problems, correct? So in this particular situation where we are saying that there's a kite flying at the height of 500 meters, right? When I say if angle of elevation is 60 degrees, find the length of the thread, right? Then we get the situation that is 500 meters, the height of our kite, this is angle of 60 degrees, and then we say, well, now let me solve using a different thing. The sine of 60 degrees is equal to opposite over hypotenuse. We say 500 over, let's say, length of the thread, L. So that means length of the thread is equal to sine 60 divided by 500, correct? Now, length of the thread will be 500 divided by sine 60, correct? We'll cross multiply. 500 divided by sine 60, correct? And what is sine 60? Sine 60 is square root 3 over 2. Right? Therefore, we get length equals to 500 over square root 3 over 2. That is 1000 over square root 3. So we can use our calculator and find the answer. So 1000 divided by square root 3, which is equal to 577.3, or approximately you can say 577 meters. Of course, that length has to be greater than 500. It's the hypotenuse. So that is the answer for this situation, correct? Now, this is how you are going to do sine and cosine. And I'm going to take a series where we are going to use these standard special triangles and we'll find different trigonometric ratios. But tan, I can tell you, many times height and distance problems. Find the height of a building, of a tree, things like that, or width of a river. All those examples we use tan, right? Cosine is used if I say a ladder is leaning at an angle of this, and if the length of the ladder is given, how far should it be from the wall? So in that case, we can use cosine. Variables to be used in that case will be distance from the wall, right? And you know the hypotenuse and the angle. So cosine is the best option to use. So in this question we learn in which situation what trigonometric ratio should be considered. Right? It's a very, very important question for you to understand. I prefer that you go through this video once again, try to visualize different situations and give your own example for the situation where sine should be important or where cosine or tan could take its place. Thank you.